Now, in yesterday's lesson, we talked about proving an identity by using the fundamental identities. We went over example 2, proving an identity. We talked about adding the fractions first, then using our Pythagorean identities to simplify. Then we used some basic algebra to switch 1 minus tangent of x quantity squared to 1 minus tangent of x, 1 minus tangent of x. That simplified things very nicely. Then we moved on to example 3, which is again adding fractions and simplifying. And we also talked about example 4. We're going to be setting up the difference of squares, which is again using the conjugate. So we took the left side, cosine of t over 1 minus sine of t, multiplied by 1 plus sine of t over 1 plus sine of t to set up a difference of squares in the bottom, to give us cosine squared of t on the bottom, so we can cancel out a cosine. We did pretty much the same thing for b, except again it was just a difference of squares on the top. In example 5, we're going to be working from both sides. It's a little different type of setup, a little different type of proof. With a little hard work and perseverance, you should be okay. First things first with example A. We have a cotangent squared of u over 1 plus cosecant of u. So we can change the cotangent squared of u into cosecant squared of u minus 1. Once we do that, we can see that cosecant squared minus 1 is really just a difference of squares. So we can change that to cosecant u plus 1 over times cosecant u minus 1. All of that over 1 plus cosecant of u. You should notice then that cosecant of u plus 1 and 1 plus cosecant of u are the same thing. So they can cancel out. We left with cosecant of u minus 1. But that isn't cotangent of u times secant of u minus tangent of u. So what we're going to have to do, we're going to have to look at the right side now and simplify that as well. We can do that by switching everything to sines and cosines. And then distributing the cosine over sine. So we'll be left with 1 over sine of u minus 1. We can then see that because 1 over sine of u is really cosecant of u, minus 1. Because they both equal the same thing, here's the next thing that we can do. Which is really kind of neat, especially with the SmartBoard software. We can move this up. Then we can move this red part to where it needs to be. Then it will equal the blue here, and we're done. So our proof will flow like this. That's how the proof will flow. That's how you work from both sides. In letter B, it's pretty straightforward on this one. We really don't have to work from both sides. We can start by making the sine squared of x cosine cubed. We can change that into sine squared of x times cosine squared of x times cosine. Those are exactly the same things because cosine squared times cosine is cosine cubed. The next step then would be to change cosine squared into 1 minus sine squared using a Pythagorean identity times cosine of x. If we distribute the sine squared, we'll have sine squared of x minus sine to the 4th x times cosine of x, which is exactly what we wanted in the original problem. So sometimes you do need to work from both sides, other times you don't. Now in example 6, we're proving an identity useful in calculus. So we need to prove that sine squared of x times cosine to the 5th of x is equal to sine squared x minus 2 sine to the 4th x plus sine to the 6th x times cosine. We'll do this just like we did example 5b. By working with this way, we can change cosine squared into cosine squared, or cosine to the 5th x to cosine squared times cosine. Just like we did in example 5b, we can change cosine squared to 1 minus sine squared. Do that twice. Now instead of distributing the sine squared in right away, let's simplify the 1 minus sine squared times 1 minus sine squared. So 1 minus sine squared x minus sine squared x, so that would be minus 2 sine squared x plus sine to the 4th x, all of that times cosine of x. Now that we took care of our parentheses over there, we can take care of the distributing. So I have sine squared x minus 2 sine to the 4th x plus sine to the 6th x. All of that times cosine of x, which is exactly what we wanted in the original problem. Moving on to B, we're going to do pretty much the same thing we did in example A, with a little bit different things because we're only dealing with sine. So we have sine to the 5th x, which I can make sine squared x times sine squared x times sine of x. Now, if you look at our answer that we want, it has cosines and sines. So you think back to your Pythagorean identities and say, well, sine squared is equal to 1 minus cosine squared. We can do that twice. Now, if we FOIL out the 1 minus cosine squared, we'll have 1 minus 2 cosine squared of x plus cosine to the 4th x. We're going to have that multiplied by sine of x, which is exactly what we want. Now, I do have 2 discussion questions for you today. What is the first step to verify this identity? 1 minus cosine of u times 1 minus cosine of u, all of that over cosine squared u, equals tangent squared u. Also, tangent of x over secant x minus 1 equals secant x plus 1 over tangent of x. I hope you enjoyed this video over verifying trig identities, working from both sides, and proving identities useful in calculus. If you should have any questions, come see me in the morning or after school.